All right, so today we'll look at 3.1 and some of 3.2, measures of central tendency. So the first one we're looking at is the mean, which is your average. Another word for average. So in statistics, very rarely do you see the word average. They will use the word mean, but it's the same thing as your average. So what you would do is add up all your data values and divide by the number of data values that you have. And once again, I already have these written out. So if I move too fast, let me know, because of course I can't see all of you. So just a small example, small data set. If our data set consists of 1, 2, 3, 4, and 5, and I wanted to find the mean, I would add up 1, 2, 3, 4, and 5, and then divide by the number 5. And we divide them by the number of data values that we have. We have 5 data values, so we divide by that. And that means my average, my mean is going to be 3.
Hey, Mr. Tucker, sorry I'm like 10 minutes late. My computer wasn't connecting. So
It's
so
all
annoying.
good.
I was so annoyed. I had to restart my whole computer and everything, but I got it now, so.
It's all good. You're fine. Yeah, we just got started. First
Okay.
thing we talked about is the mean. That's what this is
Okay.
right here, the average. So you're good to go.
Okay. Morning, guys.
Good morning.
All right. Scrolling up a little. Next one is the median. Remember our mean, like I said, is another word for the average. Your median is another word for the middle or middle value, or you can just think about the middle value when you look at the median. Now the first step in finding the median is to list your data values from least to greatest. So don't forget that, because a lot of people miss out on that first step. And if you don't do that, you will get the wrong answer going forward. So when it comes to your median, if you want to find your median, you have to list your data values from least to greatest first. And then if the number of data values is odd, you're going to take the middle value. If the number of data values is even, you're going to take the mean of the 2 middle values. In other words, the average of the 2 middle values. So if you have an odd number of data values, you will have a middle number. If you do not have an odd number, you have an even number, then you won't have a middle number. So you'll take the 2 middle values, add them together, and divide by 2. All right, let's scroll up. Move up too high, let me know. So once again, a small data set, excuse me. So my data set, the first data set was 1 through 5, 1, 2, 3, 4, 5. That's an odd number of data values, so I should have a middle number, and that middle number would be 3. So my median would be 3. But if I have another data set, let's say if I went 1 through 6, like I did in the second set, I have an even number of data values. So what I would do is take the 2 middle numbers, which is 3 and 4, add them together and divide by 2, and that gives me 3.5. So notice that 3.5 is in the middle of the 3 and the 4, which is in the middle of your whole data set. So it's still the middle. And basically your median, you will split your data set in half. Let's see, did I write that down here? Yep, that's the next sentence. The median separates the data set into halves. All right. Scrolling up. All right. So your mode is the value, the data value that appears the most frequently. It is possible to not have a mode. It's possible to have more than one mode. If a data set is considered bimodal, then that's two modes. If it's multimodal, that means it has more than two modes. So most of the time when you have a large, very large data set, that's when you look into bimodal versus multimodal and all that stuff like that. But yep, it is possible to have more than one mode. Once again, don't let me scroll up too fast if you're still copying something. All right, so in the data set example that we have 1, 2, 7, 8, 9, 6, 7, 8, 5, I say 8, 5, 5, 2, 9, 7, 6, 5, 1, 3, 4, 7. So your mode would be 7 because 7 appears the most times.
Would that be considered a multi-mode or mod?
No, nope, it would be multimodal if you had, let's say, if you had a data set that had 7, 5, and 8 that appeared the same amount of times, but everything else appeared less. So that
Okay.
would be 7, 5, and 8. So you would be listing, 7, 5, and 8 as your modes.
Okay. Okay.
Mm-hmm.
Okay. Cool.
But since 7 appears 4 times, nothing else matches that 4 times, then it would be just 7. All right. Questions before we scroll up?
I'm good.
Just a point here about being resistant to outliers. When we talked about outliers briefly last class, and you should have ran across the term outliers in your definitions, or you will if you haven't done it yet. A summary of data is said to be resistant if outliers, in other words, very extreme values, your outliers very, very large or very, very small in comparison to your data set. So if your outliers to the data set do not affect it. So what I mean by that, so look at this first one. If we have 1, 2, 3, 4, 5, we already discussed that our mean and our median is going to be 3. All right, those are examples that we've done previously. If you were to add up your data values, divide by 5, you'll get 3. Then your middle value here would also be 3. All right, so what does it mean to be resistant? So now, if I were to change that last data value to 500 instead of having it as 5, 500 will be an outlier in comparison to 1, 2, 3, 4. So if I were to add those together and divide by 5, I get 102. That will be the average. But notice my median is still 3. All right. So the median didn't change, even though I have an outlier. So what this means is that the median is resistant to outliers. So that's what I just reemphasizing what it means for a summary of data to be resistant. And so your mean, your median, all of these things that we just finished talk about are summaries of data. You know, the mean is the average of your data set, you know, summarizing your data set. The median, the middle value of your data set. You know, your mode is telling you how many times or what data value appeared the most frequently. So it's just a summary of your data, and it tells you different details about your data set. So this right here letting us know that our median is going to be resistant to outliers. So in other words, having an outlier does not affect the median, but having outliers does affect your mean. You know, it raises your, it can either raise your average or make it smaller. All right, so those are the data summaries that are in 3.1. Questions before we roll to 3.2? All right, scrolling up. All right, so measures of dispersion. Dispersion is the degree to which the data is spread out. In other words, dispersed. All right, first one, we're looking at a range. You have your largest data value minus the smallest data value. So if I have 1, 2, 3, 4, 5, I would take 5 and subtract 1 from it, and that would be 4. That's how you would find your range. All right. Standard deviation measures how far a data value is from the mean. And your variance is the standard deviation squared. And it's just another way to measure the spread of data. All right, so this book doesn't emphasize the calculation of the standard deviation or variance, but the application. So what I need you guys to do is find something that is reliable for you, you know, whether it's app calculator website or something of that nature that will calculate the standard deviation and the variance. One that I know that works fine is easycalculation.com. I'm not asking you to buy anything, but some people have chosen to do that in the past when they purchased an app because they were going to use it for other things or whatever. Easycalculation.com is free. Most things out there are free for you to be able to calculate the standard deviation and the variance. But all you want to do is be able to type it in and then hit enter. So you want an app, calculator website, or something of that nature that will help you calculate the standard deviation and the variance. Statcrunch, remember we mentioned Statcrunch when we were going through My Math Lab Helps. Statcrunch can do it as well. I just got to get used to the system, that's all. So let me do this. How would I do it? So the best way to do it is to go easy calculation. This is if you're going to use easycalculation.com and then type standard deviation. And then the first one that pops up will be that. I believe you guys are, yep, okay, just making sure you're on the same page. So, and always pay attention to the directions. Each website or calculator tell you to do something different. This one tells us to enter all numbers separated by comma. Some will say separated by space, some use semicolons, and so on. So the example I gave you to test is 62, 88, 77, 68. 2, 88, 77, 68. Make sure I got my numbers right. 288, 77, 68. All right, so I got my data values and hit calculate, and there it goes. And always, and we're gonna talk about the notation in a second, make sure you pay attention to what they're asking of you if they want. If you're dealing with a sample versus the population. Population, for example, let's say we talk about the student body of TCC, the whole student body of TCC would be the population. This class will represent a sample of that population. So make sure you pay attention to the details of whatever problem you're dealing with. Here we have 11.3 and then 1.28. Also pay attention to, 128, not 1.28, 128. Also pay attention to my math lab and what decimal place they want. Sometimes they ask for tenths, sometimes they ask for hundredths, and so on. So be careful with that. So go back to our notes. And so that's what we should have gotten. And this was a sample, it was only 4 data values. So this was a sample, so that's why we used, 11.3 and the 127. I think what I did was squared 11.3. Yeah, that's why I got at 127.69. But the more accurate value was what was given to you on easycalculation.com. I think it was 128. And so this, what's in red right here, was just someone had asked me, just emphasizing the actual formula. And so most of the time, most people don't want to know the formula anyway. But it can be involved, especially when you get higher than 20 data values. But if anybody wants to sit back and talk about the actual formula, most definitely let me know. But you're not required, because like I said, this book emphasizes the application, not necessarily the calculation. So you just need to find something that's reliable that will help you be able to find the standard deviation and the variance. All right, so before we go to notation, any questions on what I said there? And so you can use this example to make sure that what you're using is reliable. Like I just showed you, easycalculation.com works well. If not, and I'm not getting any endorsements from easycalculation.com, so no money involved at all. So use whatever you like, whatever's comfortable for you, and make sure you have something that that's reliable. So now when we look at notation, when it comes to statistics, notation will matter, because you seeing certain notation will let you know whether you're dealing with a population or the variance. So the data value X, your data value will always be X. And here we have this kind of like a U symbol, but actually is Greek letter mu. We have this extended stem right here. When you see it in the book, you'll see that it's way different, but it is similar to see the U, but it represents the population mean, the population average. Here, this letter O with the stem sticking out is lowercase sigma. right? Lowercase sigma, that's going to represent the population standard deviation. Now, capital sigma, and I think I have this down here somewhere. Nope, I don't. So capital sigma is right here. So that's capital sigma, and that represents the summation of your data values. If I were to do sigma x, that means just add up all of your data values. So summation is what sigma, capital sigma, represents. Sigma squared is the population variance. Remember, we already mentioned that your variance is your standard deviation squared. And then capital N will represent your population size. All right, any problems with me scrolling up? All right, so now looking at your sample notation, X bar, any variable with the bar over it would just be that variable bar. So that's the example I was emphasizing here. So if you had a bar over Y, that would be Y bar. If you had a bar over A, that would be A bar. So X bar will be your sample mean. So if you see X bar, that's the average of your sample. S is your sample standard deviation. S squared will be your sample variance. And then lowercase n is your sample size. All right. Questions on any of those?
No, but would you mind just sitting there for 1 second, just so I can write them all down real quick?
Okay, yeah. Did you say you need me to scroll up or just sitting right here?
Just stay right there for like
Okay.
a minute, not even.
Yep. Not a problem, not a problem. I believe that is it as far as this. Yep. Mhm. All right, scrolling up a little. Empirical rule. I'm gonna save that for next class. All right. Are we good to go? Making sure we're straight.
I'm good. Yeah, thank you very
Okay.
much.
Yep, not a problem at all. All right, so let's look at the rest of 3.2. Hold on 1 second. Yeah, let's do the rest of 3.2. So 3.2 has the empirical rule as well. And it says approximately, I did APP for approximately, 68% of the data is within one standard deviation of the mean. Approximately 95% of your data is within two standard deviations of the mean. And then we have a third one as well. Give you a chance to write that though. All right. I don't know why I did that, but yeah. So then approximately 99.7% of the data is within 3 standard deviations of the mean. So this diagram emphasizes those 3 statements. Remember I told you about the normal distribution, your bell-shaped curve. It reflects or is symmetric about the mean. You have your mean right here in the middle. Your mean is right here in the middle. And so to the right of your mean is 50% of your data. To the left of your mean is 50% of your data. And so those percentages, notice how we have 34%, going from the middle, we have 34%, 13.5%, 2.35%, and 0.15%. Those percentages do not change. They will always be the same according to your normal distribution. So your mean is in the middle. And notice how it says within, the first one was within 1 standard deviation of your mean. So 1 standard deviation is right here, is 68% of your data. And then 2 standard deviations, if you go out, when you add up 13.5, 34, 34, and 13.5, you'll get 95% of your data. Then within 3 standard deviations, you're talking about adding 3 and subtracting 3 from your mean. You'll have 99.7% of your data. And then on the tails, that's 0.15 a piece. If you add those together, that's 0.3, which will add up to 100%. 0.3 plus that 99.7. And that's how according to your empirical rule, that's how your data will be distributed. And the use for it, you can use it to, according to observations, predict weather and all the good stuff like that. Yeah, so we'll do an example that emphasizes this in a second. Just try to give everybody a chance to write. And while you're finishing up, you have your mean in the middle. You add a standard deviation to the right, subtract 1 from the left, that goes out 1 standard deviation. Add and subtract again, right and left. That gives you 2 standard deviations out. Then add and subtract 1 more time to give you 3 standard deviations out. So that's what we're going to do in this next example. All right, anybody holding on? Can I scroll up? Scroll up, everybody good? All right. So the mean IQ score of students enrolled at University A is 100 and the standard deviation is 16.1. So notice they give us the mean and they give us the standard deviation. So once again, emphasizing the application of your standard deviation and your mean, not necessarily calculation. So determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. And B, determine the percentage of students who have scores between 67.8, 132.2, and determine the percentage of students who have scores above 132.2. So once again, I give you a chance to write. All right. So, first of all, recognizing what they gave us. They gave us the mean, which is 100, standard deviation 16.1. And all I was emphasizing here is that I decided to call them, let me see what we're dealing with. Yeah, so we're looking at the university. So I use the population symbols, the population student body. So I called it mu and sigma. But if you wanted to call them sample, I was just emphasizing that you would use X bar and S if you were dealing with the sample mean and sample standard deviation. So really, don't need arrows right here. Just emphasize the notation. That's all. So now, when we go into calculate, what I'm going to do now is just set up the empirical rule, how you would find it according to the information that we have. When we go here, notice we have a right side of the mean, which is over here, left side of the mean, which is over here. So what I'm going to do is calculate right side first and then calculate the left side. In order to calculate the right side, all we're going to do is add a standard deviation 3 times. To calculate the left side, we're going to subtract the standard deviation 3 times. So, well, I guess I don't have to rewrite it. That's what we did here for the right side. I did mu plus sigma, that's 100 plus 16.1. In other words, your average plus your standard deviation. So that gave me 116.1. Then you would add it one more time. So 16.1 plus that 116.1 gives us that 132.2. Then add 16.1 one more time, and that'll give us 148.3. And then to find the left side, you would do the same thing, but with subtraction. So notice we have our mean. We subtract the 16.1, that gave us 83.9. Subtract 16.1 again, that gives us 67.8. Then subtract it one more time, and that gives us 51.7. All right, make sure we're okay with what we've done in order to figure out right side, left side of your mean with the empirical rule. All right, scrolling up. So when you look at what we have, and I got all of these, see if I can erase this stuff. Yeah. So once again, the percentages don't change. That 34%, 13.5, 2.3, 0.15 on both sides of your mean do not change. But notice what we're going to fill in are the numbers down bottom. So we have our mean in the middle, which was 100. And on the right side of our mean, 116.1, 132.2, 148.3. Then on the left side of our mean, 83.9, 67.8, 51.7. So before we look to answer those questions on how we set up our empirical rule. All right. So let's look at what would they ask us out of number 1? It says determine the percentage of students who have IQ scores within 3 standard deviations of the mean according to the empirical rule. So we really didn't have to do any calculations for letter A. So that goes back to what the empirical rule states, that 99.7% of the data is within 3 standard deviations of your mean. And that's what they asked us. So A would have just been 99.7%. All right, questions on A? Like I said, A was just a statement of the empirical rule. 99.7% is always going to be the case according to the empirical rule of the amount of data that's within 3 standard deviations of your mean.
That wasn't that.
So again, you broke up?
I said that one wasn't that bad.
Yeah, that was just off of the statements. Right. So now this next one depends on our calculation. Determine the percentage of students who have scored between 67.8 and 132.2. So 67.8 is right here. 132.2 is right here. So what I would do is add up the percentages in between. So 13.5, 34, 34, and 13.5 gave you 95%. So you could actually ask that about any of these. You could say, what's the amount of data you expect to be between 83.9 and 148.3? And you would just add up the percentages in between those data sets. So like I said, this is something you could use even when it comes to predicting the weather. What's the chance of having a certain weather temperature, between this, that, and the third. So you could like take these percentages and find them out and add them up accordingly. And same thing with hurricane season. All of it is based on previous observed data. And so based on what you've experienced before now, what can you expect? And then C, determine the percentage of students who have scores above 132.2. So 132.2 is right here. And what's above that is 2.35 plus the 0.15. So just 2.5% of the data you would expect to be greater than 132.2. All right. Questions? Any questions?
The 0.15 was that number in the question, right?
When you say is it in the question, what you mean by
I
that?
what I'm trying to say is like, where exactly did it come from?
The percentages?
No, the 0.15. Where's that on the screen? I guess like where would that? Oh, on the very okay.
Yeah, right here on the tail end. You talking?
I didn't see that one. I was looking on the opposite side. Okay, cool.
Okay, yeah. Now, and don't forget that if it's going to be over here, then it has to be over here as well.
Okay.
Because it's symmetric. So whatever's going on the left side also goes on the right side.
Okay. Got it. Thanks.
All right. Questions. So this is where we're going to stop today. There's no rush. Next class, we'll do 3.4 and 3.5, chapter 3, or not chapter 3, section 3.3. You're not held responsible for it, so you shouldn't see it in your homework. So there's only 4 sections in chapter 3. So 3.4 and 3.5 pretty much are relatively short, and we would knock those out on next class. So yeah, trying to not move but so fast, but at the same time, you see there's only 4 sections in chapter 3. There are only 3 sections in chapter 4. So that's why I say make sure you jump on top of this chapter 1, chapter 2 stuff, because next thing you know, we'll be done with chapter 4, and then you have a lot of stuff that you're looking at, so you want to stay on top of this stuff. Questions, concerns, comments before we close? Good, straight.
Oh,
Okay.
I think I'm good. So.
Okay. Okay. And you see what we're doing right now is not really hard calculation, but it's the process. It's all about emphasizing the process. And so, yeah, you pay attention to the process, you guys should be good as far as this stuff is concerned.
I'm sure
So,
when I do the homework, I'll have some questions next class.
okay, yep. So the floor will be open for that, most definitely. Just let me know, and we can knock them out. So with that being said, you guys have a great day. Like I said, knock out that chapter 1, chapter 2 stuff, and then let's look at getting into chapter 3. So you guys have a great day, and I'll see you on Thursday.
Awesome.
Thank you. You too.
All right, take care.
Thank you very much.
All
Bye.
right. All right.
Thank you.
Bye.
Good, take care.